Hello students, I am Sucheta Mori from St. Vincent Perotti College of Engineering and Technology. Here we discuss the tracing of curve in Cartesian form. Unit number 2, Forms of curve. There are three forms of curve: Cartesian form, polar form, parametric form. Here we discuss the Cartesian form method for tracing these curves. First point is curve through origin. If the equation does not contain any constant term, then the curve passes through origin. For example, y square equal to 4ax. Here a is the constant value but which is the coefficient of x, not a separate value. Therefore, the curve passes through origin. Similarly, for x square equal to 4ay, the curve does not contain any constant term, therefore passes through origin. Second example is x square plus y square equal to a square, which is the equation of circle. Here a square is the separate constant term, therefore the curve does not pass through origin. This is the equation of circle whose center is 0, 0 and radius is a. Second point is symmetry. If the equation contains only even power of y, then the curve is symmetrical about x-axis. That means, for example, y square equal to 4ax. Here the power of y is 2, that means even, therefore this is symmetrical about x-axis. Now, second is, B point is, if the equation contains only even power of x, then the curve is symmetrical about y-axis. Now, here x square equal to 4ay, here x has even power. Therefore, symmetric about y-axis. Third point is tangent at origin. The equation of tangent at origin can be obtained by equating the lowest degree term to 0. Now, for example, in this equation, here we equate the lowest degree term to 0. Now, lowest degree term is x square minus y square. If we multiply by x to this value, then we get x cube plus xy square. Therefore, lowest degree term is this x square minus y square equal to 0. On solving this, we get y equal to plus minus x, which are the required equation of tangents. Fourth point, the point of intersection with the axis. We already know that if we substitute y equal to 0, then which gives the equation, which gives the intersection with the x-axis, and if we put x equal to 0, which gives the point of intersection with y-axis. If we consider this equation of the circle, then point of intersections with x-axis a0 minus a0 and y-axis 0a, 0 minus a. Fifth point is region in which the curve does not lie. If the value of y is imaginary for certain value of x, then the curve does not exist for such values. For example, y square equal to 4ax. For negative values of x, y is imaginary. Therefore, the curve does not lie in second and third quadrant. If the values of x is imaginary for certain value of y, the curve does not exist for such values. For example, x square equal to 4ay. For negative value of y, x square is negative, that means x is imaginary. The curve does not exist for these values. Asymptote. There are three conditions. No asymptote. If the asymptote is present, then parallel to x-axis and parallel to y-axis. For non-value of y, x tends to infinity, then the curve has no asymptote, or vice versa. That means for non-value of x, y tends to infinity. Now, for example, y square equal to x square minus x to the power 4 Leibniz gate. This it has no asymptote because for the value of y, x tends to infinity or vice versa. Asymptote parallel to x-axis, it is obtained by the equating the highest power of x to 0. Now highest power in this equation, highest power is y minus 4. Highest power is 2x square. The coefficient of this value is y minus 4. Equate this equal to 0, then we get the equation of asymptote y equal to 4. Third condition, asymptote parallel to y-axis. It is obtained by equating the highest power of y to 0. Now here highest power of y, the coefficient is x minus 2. Equate this equal to 0. Therefore x equal to 2 is the equation of asymptote. 7th point table. Consider the different values of x and y in the range of given values y and x. Find out, plot the points and trace the curve by applying all these steps. These are the important steps to trace the Cartesian curve. Now we discuss one example of this. Trace the curve Leibniz gate y square equal to x square minus x to the power 4. Now first step, we consider the equation and find out the origin. That means the curve is passes through origin or not. The equation does not contain any constant term, therefore the curve passes through origin. Symmetry. Now here x power is 2, x power is 4. That means here even power of x and also the even power of y. Therefore the curve is symmetric about x-axis and y-axis. Third point is tangent at origin. Now here we equating the lowest degree term y square minus x square equal to 0. Therefore y equal to plus minus x, which gives the equation of tangents. Then point of intersection with the axis. Put y equal to 0 in this equation, we get x square into 1 minus x square equal to 0. That means x equal to 0, 0 and x equal to plus minus 1. Therefore, whenever x equal to 0, 0, there is a cusp at this point, that means at origin. And point of intersections are 0, 0, 1, 0 and minus 1, 0. Now, fifth point, region in which the curve does not lie. For x greater than 1 and x less than minus 1, y square is imaginary. Therefore, the curve does not exist for this value. Asymptote. For none value of y, x tends to infinity or vice versa. Therefore, the curve has no asymptote. Now, the curve exists between minus 1 to 1 value of x. Therefore, we consider in this table from the values of x from minus 1 to 1. You can take any values and substitute in the given equation and find out the corresponding value of y and plot these points. Now, here the curve passes through origin, first point, then symmetry about x-axis and y-axis, then tangents y equal to x and y equal to minus x, then point of intersection with the x-axis 0, 0, 1, 0, minus 1, 0. There is no asymptote. The range is from x values minus 1 to 1 and all these points are verified. Therefore, this is the required result. Now, applications, that means we can find out the length of the curve, area of the curve, surface area and volume. The process of finding length of the curve, we call this as rectification. The process of finding area of the curve, we call this as quadrature. And we apply the given formulas for finding the respective values. In this way, we can solve the problem of tracing of curve and find the area, volume, surface area and length. Thank you, students.